In this segment, we'll take a look at the various kinds of models that you can entertain for RI-LTA with covariates. So on slide 71, we have 7 different models. The first one being, again, the model without covariate as a comparison. And then model 2, the model of key interest to us in RI-LTA, namely poverty influencing the random intercept factor f. So that adds one parameter, the slope of that regression, and we see a drastic improvement in the log likelihood with about 200 points here. Testing in model 1 versus model 2, we get a chi-square difference test with 402, the value of 402 with 1 degree of freedom, so strongly significant. And we would reject model 1 in favor of model 2. And the big value also speaks for model 2. And once again, we note that in the chi-square difference testing, we take the approximation of not using the scaling correction factors because they're close to 1. But you can do the scaling correction factors and get a chi-square that's more precise. Model 3, then we try to replace f with c1 to see if that is just as good to use. Well, that improves the log likelihood relative to the first one, and it is a significant improvement. Chi-square is 20 with 2 degrees of freedom, so you would choose model 1 over model 3. But the BIC is not as good. The log likelihood and the BIC are not as good as for model 2. For model 4, then, we have both C1 and F on poverty, and that gives us a slightly better log likelihood value than having F alone as in model 2. But that's a chi-square of 2 with 2 degrees of freedom, so that's not a significant improvement, and we might just as well stay with model 2, so we choose model 2, the bolded model here, in this set of 4 models. And note that none of these models imply that we have any effect of the covariate on the transitions. F and the starting point C1, that effect does not affect the transitions, just the level, so to speak. Now, when it comes to transition effects, we have the main effect and the interaction effect possibilities. Main effect model, we can have C2 through C4 on poverty and F on poverty, or C1 through C4 on poverty and F on poverty. If you compare model 5 to model 2, yes, we find model 5 to be the better one. We reject model 2 with a chi-square difference of 44 with 6 degrees of freedom. If we use this model, model 6, which corresponds to output 8 that we discussed in segment 14, you would also, if you compare that to model 5, you would still work with model 5 as the simpler model and has a better BIC as well. Now, interaction effect model output 9, where we have interaction between x and the latent class variable at the previous time point, you get an improvement of the log likelihood relative to, say, model 5. But it's an improvement that's not really significant. With 14 degrees of freedom, the chi-square difference is 16. So you would choose model 5 here as well. And model 5 is the one with the best BIC as well. So model 5 might be the model, although model 6 wouldn't be too bad to use as well. Both of them have good BIC values. And it's interesting that the best BIC with the regular LTA is so much worse, 43,500 instead of the 40,000 that we're at with the RI-LTA. We can also check the class percentages, no covariate, and adding the poverty covariate. And for the 3 classes and the 4 time points, we find that the results are very similar. 95.50 versus 94.51 for the fall, and all the way to the last time point 1,297, 2,296. So the class formation doesn't seem to change very much by adding a covariate. And no need for a three-step analysis. Same thing was found for regular LTA at the top here as for the RI-LTA that we just looked at. But still, we note how different the class percentages are between regular LTA, be it with or without covariate. 69 versus 95, 94. 81 versus 97, 96. Here's an interesting slide, 74. Transition probabilities obtained from the LTA calculator. Here's the case for regular LTA first, and then we're going to take a look at the RI-LTA. So this is model 3, run 6 that we talked about earlier. So you consider poverty equals 1, poverty equals 0, and the transitioning is from C3 to C4, that is from fall of first to spring of first. So the last two time points. So here we have the transition probability matrix for poverty equals 1 and the more fortunate group of poverty equals 0. So take a look, for instance, at this row starting in class 2 of fall of first grade. We have the probability of staying there 0.226 versus going on 0.764 for the poverty group. And for the non-poverty, the more fortunate group, you have a smaller probability of staying in that class 2 and a higher probability of going on to class 3, as would be expected. Now you could of course test differences in probabilities here and using non-symmetric confidence interval, but what's I think a more effective use of these numbers is to look at odds ratios. We have 4 numbers that we can summarize into 1. So odds ratio for C4 equals 2, given C3 equals 2. So C4 equals 2 versus C3 equals 2. So that's probability 226 divided by 764. That's the odds of staying in the middle class, staying in class 2. For poverty equals 1 divided by the similar ratio for poverty equals 0. So odds, 2 odds divided, giving us the odds ratio 2.27. And for a second, let's go straight here to the interpretation. The odds of staying in class 2 versus moving to class 3, that's not something we want. That's an undesirable outcome. Is 2.27 times larger for those in the poverty group than those not in the poverty group. So that's odds ratio, summarizing the 4 numbers up here. And just for fun, you can check then the odds ratio is 2.27. The log of that is 0.82, which is the estimate of G2 corresponding to the notation in our transition tables expressed in loaded form. So e to the power of G2 is 2.27, but G2 itself is 0.82, where G2 is C4 class number 2 regressed on poverty. Now this is comparing to the last class, whereas Mplus instead focuses on or also adds the output using the diagonal class as a reference class. So then you divide these numbers a little bit different. You take 7.764 divided by 2.226 instead of the other way around, and 0.881 divided by 0.115, and you get 0.44. So that's the odds ratio for moving to class 3 versus staying in class 2. Moving to class 3 versus staying in class 2 is lower for those in poverty than those not in poverty. So the odds is 0.44 lower for those in the less fortunate group. Now, the odds ratios and their confidence intervals are given under the heading Covariate Effects on Transition Probability Odds Ratios. You note also that for a regular LTA that we're talking about on this slide, 5 out of these coefficients for C2 through C4 in poverty are significant. So most of them are significant. So in this case, we really need those effects included. And that manifests itself by these numbers being different. This being higher than that, this being lower than that. Now, if you do the same thing for RI-LTA, this is model 6, that is run 8, the output from run 8. Once again, C3 to C4 transitions, and poverty equals 1, poverty equals 0, looking at the same type of classes here and here, we see less of a difference between poverty equals 1 and poverty equals 0. And in fact, only 2 of these C2 through C4 effects that indicate effects of poverty on the transitions are significant. So there's less of a need to include those effects. And one could say actually that most of the effect of poverty is on the random intercept factor F. That is not an effect on the transitions themselves. And the effect of poverty on F indicates measurement non-invariance with respect to poverty. So poverty explains the random intercept factor F, that is the individual differences in the response probabilities coming from F. And F then being the time invariant measurement non-invariance, which is another way of looking at it.